Let g be the function given here, where k is constant. For what value of k does g have a critical point, right? So a critical point means g prime is 0 or g prime does not exist. But because we're looking at, there's no denominator here, so I don't have to worry about the does not exist. So basically, my job is to find g prime and then set it equal to 0 and solve. So g of x is an x squared e to the kx. So there's my u and my v. I'm hoping what we're noticing here is that it's really important you know the definition of things. When you hear g has a critical point, your brain has to jump right to g prime equals 0. So derivative is u. dv is going to be e to the stuff times the derivative of the stuff plus v, which is e to the kx, du, which is going to be a 2x, right? So the trick is we want it to have a critical point at 2/3. So more specifically, not just is g prime equal to 0, we want g prime of 2/3 to equal 0. So g prime of 2/3 is apparently 0. Well, if I plug in 2/3, that's going to be 2/3 squared e to the 2/3 k times a k, which we'll deal with in a sec, right? Plus, I'm going to go ahead and put the 2 and the 2/3 at the front, e to the 2/3 k. Great. Okay, so I think I get that 0 equals a 4/9 k e to the 2/3 k plus a 4/3 e to the 2/3 k. If I factor to solve, I'm going to start by factoring out honestly, I probably should have just yanked out one of the 2/3 to begin with, but you don't have to, e to the 2/3. And what seems to be left is a 2/3 k plus 2. Well, I know this can't be 0 because e to a power is always positive, right? So 0 equals this thing. Oh, sorry, that's a 2/3 k, my bad. E to the 2/3 k can't possibly be 0. That's a lie, right? So 0 has to equal 2/3 k plus 2. So negative 2 equals 2/3 k. Negative 6 equals 2k, and I think I get negative 3 as my k, which is probably an answer up here somewhere. It's answer A. All right. So again, the trick was knowing what a critical point means and then noticing that it's a specific value of x, right? You're not solving this without finding a specific value of x.